Yeah, so thank you all for joining. My name is Ranjan Priyadarshi, and I'm the moderator and the host for this summit. And today today and tomorrow, it's a 2-day summit. So we're gonna cover one of the crown jewels of Oracle database, which is database in memory. I will shortly share the agenda with all of you. So let's get started. Okay, so this summit is all about you, okay? And we are hosting this summit for you. And we are very excited that you are here. And I mean, it would have been best if we could have hosted this summit in person, but we'll make the best out of it. So yeah, and again, we have a very exciting agenda planned for you, and we are very excited that you're here. And Summit is also about kind of bringing people together. It's people from all different stakeholders and different areas, whether it's customers, partners, industry consultants, Oracle sales, marketing, product development, and all. And there's something for everyone, okay? And if you're new to Oracle database in memory, basically there are sessions around vision, roadmap, also customer use cases that will help you get started with database in memory. And also if you're an expert, then there are sessions around what's new in database in memory, as well as best practices and other things that will help you try new things in database in memory. So again, Summit is, there is something for everyone. Join our community, provide feedback, propose new enhancements, build something together, ask questions. Again, this summit is all about collaboration. So I will paste these links in the chat window. Please join these social media groups and provide us the feedback. Also, we want, we are inviting customers to join customer advisory board. So let us know if you are interested. Again, it will be a closed group of customers who we can work together and work on strategic things and all. So let us know if you would like to join the customer advisory board. Kind of switch gears, okay? And here we talk about a little bit about telecommunications. Everybody has seen how the telecommunications has evolved. From 1G to 5G. At 1G, the speed was like 2 kilobytes per second. And with 5G, we are talking about more than 1 gigabyte per second, okay? What is difference between 1G and 4G and 5G is all about speed, okay? So its speed definitely enables a new paradigm, and it enables new way of doing the business, okay? And what we are seeing is that, and kind of switch gears and talk about analytics, right? Many of our customers, as we have talked to, are still stuck in 1G, 2G, and 3G type of complexity. And they are working on platforms which are performing pretty slow, right? And what our ambition and goal is to kind of switch them to 5G analytic speed platforms, okay? And this is where database in memory gonna help a lot. Okay, and so speed can definitely change the way you think about your business. It can enable new differentiation, better service, new business model, and this is where our goal is to help you adopt the 5G speed for your analytics. And that's kind of the basic gist or the agenda for the whole summit. And it's not that we are just getting started. We have a lot of different customers who have already adopted database in memory. Is the largest electronic manufacturer, one of the largest automaker, and the largest retailer, and the list goes on, okay? And these, the largest, the biggest, and the best, they are adopting database in memory because they want to keep the lead in the market, and they want to improve the customer experience and all. And as we are working on digitalization and modernization and all, these fast and real-time analytics will be a necessity. They will be the key enabler. And everybody will need the faster and the real-time analytics, and it will become the table stakes. So it's time that all our customers, they start thinking about real-time analytics and database in memory now. And this is what many of our customers have seen in terms of performance. I mean, there are several customers who have seen up to 100x performance improvement with database in memory. And there are others who have seen kind of smaller improvements, but even to the extent that 4x and 3x improvement are significant. And we would like to see your names and success stories at the next summit here. So that's our goal again, and we are here to help you. Again, as a summary, Oracle database in memory is a game changer. This is a quote from our customer, and it dramatically improves the performance of all types of analytic queries. And as you hear all these different presentations, think about what application and use cases you can apply database in memory. How can you get started? And how can you get most value out of database in memory? And again, we are in the journey with you. So let us know how we can help. With that, again, kind of switch gears. This is our kind of panelist or the list of speakers in 3 different categories. We have keynotes, and we'll shortly start with the first keynote and the second keynote. And then we have customer success stories. Most of them are scheduled tomorrow. So please join tomorrow for the customers, hearing all the customer success stories. And then we also are doing the deep dive, a technical deep dive with Shashank and Andy and all. So again, this is the agenda. I sent the agenda to everyone. And the agenda, as you can see here, we are here on the session 1. And session 1 and session 2 have the same agenda. Okay, so it's kind of identical set of sessions. So if you like to join session 2, feel free. But again, it's the identical set of sessions. Session 3 and session 4 have all customer presentations and also the keynote from Ahmad. And they have different set of customers presenting. So feel free to join both the session 3 and session 4. Some housekeeping items before we start. Please ask questions in the Q&A and not in the chat window, but in the Q&A. There are several panelists here and experts here who can answer the questions. And please ask questions. And we are here to help again. And please subscribe to this LinkedIn channel. Again, I'll put this in the chat window or somewhere. And then please subscribe to this channel. Again, this summit is all about building collaboration and all. And use the social media hashtag DB in memory to talk about this event. And let's together build a solution for the future enterprises. So with that, again, we're gonna invite the first keynote speaker, Tirthankar, to the stage. So let me stop sharing and.
Hey, Ranjan, can you talk about the question answers, please?
Sorry, so the Q&A. So anybody who has questions should post the questions in the Q&A, not in the chat window. Okay, so Tirthankar, maybe you want to get started with the sharing while I introduce you.
Sure.
So our first keynote is from Tirthankar Lahiri. His topic is Oracle Database in Memory, Warp Speed for the Enterprise. Tirthankar is Senior Vice President of the Data and In-Memory Technology Group for Oracle Database, responsible for Oracle Database Engine, including tables, indexes, in-memory transactions, the Oracle Timestamp in-memory database, and Oracle's NoSQL database. Tirthankar has 25 years of experience in the database industry. He has 45 issued and several pending patents. Again, from the abstract, in-memory computing is more than simply about speed. It enables a fundamental transformation in business process. Just as air travel enabled more than just the ability to travel faster, it enabled a completely new global economy, reshaped politics, and transformed society. Oracle Database in Memory options similarly enables not just faster analytics, but a fundamental rethinking and drastic simplification of the traditional analytic platform. With that, Tirthankar, please get started.
Hey, thanks, Ranjan. Thanks for the intro. So yes, my name is Tirthankar. I manage a team called the Data and In-Memory Technologies team in the Oracle Database organization. And I'm going to talk about how Oracle Database in Memory enables massively accelerated enterprise computing. So everyone hopefully recognizes this enterprise. Let me go here. But, in the modern context, what is the need for the enterprise? The need for the enterprise is to be real time. And what does a real time enterprise mean? It's basically something that is fundamentally driven by actual data. So it's not driven by gut feeling or by instinct or by hypothesis. It's driven by real data. And a real-time enterprise is one that has to be agile, that collects data, gathers data, and responds very quickly to any changes in the data. So it's predictive. It's not just passively analyzing data and doing nothing with it. And the real-time enterprise must be efficient, that it reacts to this data, data makes decisions based on data, and continuously optimizes processes so that none of the processes are stagnant. The processes adapt to the modern to changing worlds. If like a global pandemic were to hit, that should never happen, of course, but let's imagine that in some future scenario, there's a global pandemic and the world changes. Can the enterprise adapt to that new, the new set of circumstances and still stay in business? These three things define what it means to be a real-time enterprise. There's many examples of real-time enterprises. I can't possibly cover all of them. I'm going to try just to cover a small smattering of examples. You can see examples of real-time in enterprise infrastructure with insurance companies, where the insurance companies constantly reprice portfolios, give real-time quotes based on actual data, and feedback the system continuously to improve their profitability while maintaining the right coverage for all their subscribers. Retailers often will have to use time-sensitive analytics. If I'm about to check out something in a shopping cart, that's the only chance they have to let me know that there's something else I should be looking at to buy. Or if I bought something, to try to upsell other products to me at the same time. And very often, catching the customer at right then is essential to make that sale. If I've gone away, even 10 minutes later, I'll have forgotten all about it, moved on to something else, I will no longer be interested in buying that item. So retail is a big area for real-time enterprise metrics. Manufacturing processes have to use real-time analytics to constantly monitor, quality parameters, adjust manufacturing processes based on observed tolerances and observed, potentially any defects in manufactured parts. Financial technologies, pretty much everyone has to do real-time risk analysis. There's no point, there is a point, but there's less value in identifying fraud after the fact. You really want to catch fraud before the event actually takes place, based on a lot of parameters of fraud management. So risk assessment and risk management is very, very critical in financial services based on real-time analytics. And telecom networks continuously use real-time analytics to optimize networks, to figure out which towers to use, where to route traffic, which network points are becoming congested and need to be routed around. So all of those things are essential in today's world, especially with 5G networks, where the bandwidths, as Ranjan mentioned, have become so much higher. So lots of use cases for real-time enterprises in the real world today. And that brings me to my first poll question. Now, what I'm going to do here is, there's actually 3 questions that I'd like you all to respond to. So I'm going to kick off the poll. I think, you'll see the first question as question number 1 here, but the other 2 questions you can also answer at the same time if you like. I'll check back later on to see how we're doing. But right now, let's carry on and see if hopefully I can continue past this full screen. Let me see, how do I do that? Okay, let me put it here so that I can continue. But yes, please go ahead and answer the questions to the best of your ability. You don't have to answer all 3 right now, because I'll stop when it's time to bring up the second and third question, but feel free to go ahead if you like. Now, what makes real-time enterprises hard? It's really one thing. It's not lack of technology that makes it difficult. It's quite the opposite. What's difficult, what makes real-time enterprises difficult really is complexity. That's the real enemy. If anybody here is from India, has been to India, you recognize this is a very common sight in every Indian street corner, like an electrical junction box for street lights and goodness knows what else, right? That's a very common sight in India. That's sort of the analog of many enterprises today, which have so many different architectures, technologies, different implementations that really make it difficult to make sense of the overall design. And this hurts security, hurts administration, it hurts diagnosability. When something breaks in that junction box, good luck figuring out which cable is at fault here. And makes it very difficult to be agile and efficient. All the things we need for real-time enterprises are very difficult if the enterprise looks like that. Now, and an enterprise like this actually does exist. And here's an example of one. And this is actually a very successful web company that have built an architecture with no less than, I count, 9 different data stores and transformations of data between the data stores. So what ends up happening with something like this? You have, first of all, what we call copy contagion. There's multiple copies of the same data, logical data, in different repositories, which means doing analytics is tricky because now I have to sort of deduplicate my redundant data across the different data sets. Security is as weak as your weakest engine. So if you have multiple engines, you can be sure that your security is not as good as your best engine. Consistency is tricky again because you have to copy, transform your data, and it's not clear whether you can get a consistent view across the stack. It is complex to maintain this, patch, upgrade, etc. And the only reason this enterprise can actually do this is, they are a successful web company. So they have been able to hire, MIT and Stanford PhDs who keep this thing running, update it. So yes, it's possible to do, but it's not for everyone. It's not the right architecture for, enterprises that have a different business focus. The way I think about this is there's very few Formula, One sort of car teams, Formula One race car teams. Formula One racing is for Formula One drivers and Formula One teams. Most people design cars or use cars for much more functional purposes. And, getting Formula One tech or Formula One complexity into my regular street car may not be a good fit for my needs. So this is sort of the cutting edge, the extreme edge of enterprise complexity, which is not ideal for most enterprises. So I call this die by DIY. You die by doing it yourself through 1,000 cuts. It works up to a point. If you're a highly successful, $1 trillion market cap company with, the smartest MIT PhDs each year, you can probably get away with it, but it's not for everyone. I want to show you a quick example just to walk through and whiteboard a hypothetical scenario of what would happen in just trying to create like a new sort of business in this, especially in this pandemic world. Let's just see how quickly things get really complicated. So imagine we're building a new delivery service called Megacart, because most of my life right now is spent online, and shopping online is the way we survive the pandemic. So let's imagine we're building a new architecture for Megacart, which basically contains an online delivery application with customers that place orders, stores that process orders, that there's a delivery service, deliver your order, and there's an analyst sitting behind the scenes to process business metrics and make longer-term decisions. So the app itself contains logic for transactions, for delivery and orders, and analytics for instant decision-making and for continuous optimization. So it's, that's the problem statement is quite simple. I'm sure all of you use something like this already today. But let's see how we get this running. So what we do is, the very first thing you do is you define a simple OLTP schema with indexes, and then you can bring up your database and run transactions. It's quite simple. You have customers and stores and delivery services that can run against a single database architecture with a simple schema and has fast transactions. But as I said earlier, we need more than just the transactional part of this application to make it real, to make it viable. The next thing is we need analytic indexes, because you need to analyze your inventory levels, your stores, figure out which customers need which products, etc. If I want to buy something from a store, if I want to buy a particular product, which store should I send that order to? Questions like that need indexes. So I have to build analytic indexes to answer questions like that, right? This, of course, now has added slightly more complexity, because I have to now add indexes for the queries I anticipate. This does slow down transactions, because the transactions have to maintain these indexes. And the trickiest part about this is I have to know which queries need indexes and anticipate them and then create indexes for them. So it's still simple, but it's not as simple as we began, where we had a well-formed 3NF schema with the fixed set of relationships and indexes for those. Now I have these blue indexes that are less well-defined, but are needed to make analytics possible. However, it gets worse because the business analyst needs to run longer-term reports. The business analyst needs to look at trends, look at forecasts, see which product is like to get depleted in a given, at a given time period, see which stores are highly performing stores and maybe they need a bigger boost in products or inventory. These things require really a reporting database. I mean, you typically do not run queries like that on the operational database. And what happens then is you have more than doubled complexity. You take the operational database, you move the data using extract, transform, load into the reporting database. You convert this into a different schema. You no longer have your third normal form OLTP schema. You create your star schema that record every sale fact and run the analytics against that schema. So this really adds quite a bit of complexity. And of course, there's a separate set of indexes you've got to have on that star schema. It keeps getting more complicated. A lot of these analysts require basically reports from dashboard, and the dashboards, repeatedly query the same thing over and over again. To really get the dashboard queries to work efficiently, you need not just indexes, but pre-computed summaries or materialized views. So I can look up reports like, quarterly sales or monthly deliveries or top products or top stores without having to rerun the query each time. So now I have my operational database with OLTP and short-term analytic indexes, my reporting database with the star schema, its own indexes plus pre-computed summaries. And you can see suddenly now my architecture has become a lot more complicated. The big complexity source really is the reporting database here. It adds a whole new system to manage, requires ETL logic. It's usually behind the operational database, so queries against the reporting database will not have the same results as when run against the operational database. The analytic index, like I said, slow things down. They require advanced knowledge of the workload. They make the database bigger. And then, of course, the pre-computed summaries, the materialized views on the reporting database, add additional complexity. They also, typically most materialized views are not synchronously maintained. They're maintained asynchronously. So they lag the source tables, and they add additional load to the database to keep the tables maintained, and they make the database size bigger. So we've made this what used to be a simple architecture quite complicated by adding another database with another schema and another set of reporting refresh mechanisms. What we really want is to be simple. Like I said, we want to be real time, and real time means I really don't want to manage multiple systems and multiple views the same data. I want my data to be as simple as possible. So for that, what I really want is a single database with my indexes and nothing else. Now, is this possible? Can I do this? Can I run without predefined indexes or summaries? Can my transaction analytics all run against the same operational database? Is that possible? Well, I wouldn't ask the question when possible. Of course, the answer is yes. And the answer is yes because of this great technology, which this summit's all about, which is called database in memory. Now, database in memory is based on a fundamental premise. We have two different ways to represent data in the database. You can represent data in rows, which is typically the normal model for transactional databases. It's great because rows tend to be self-contained. If I want to insert a new row, everything is together. So OLTP runs fast on the row format. But if I want to run analytic reports where I'm looking at total sales in a region, I'm better off with the data stored in column major format. So I can aggregate my sales data, scan my region data very quickly because all my column data is stored together. So the premise, the thesis here is let's use both formats simultaneously. Let's not try to use one format and get its benefits, but suffer its drawbacks. Why don't we keep the data in both formats at any given time? Transactions will use the existing row format, which is typically loaded in the buffer cache as highly efficient representations of disk blocks. And the analytic workloads will use the column format automatically. This is the new in-memory format, which allows very fast reporting based on techniques like SIMD vector processing. I'll talk about later on. So the transactions can get very, very large transaction throughputs, tens of millions per second, whereas analytics will achieve billions of rows per second scan speeds using in-memory column processing. And the determination of which format to use is automatic. So there's no user intervention required. Once the table is loaded in memory, the optimizer will decide which memory area to use to service a query. Okay, so this brings me to my second poll question. Please do ask. Please try to answer this question while you're, listening to my presentation. I'd like to know how much you know about database in memory. It'll also help us, gauge how much detail we should go into for the rest of the sessions. So please don't be shy about admitting you know nothing about it if you don't. Do tell us what you think, how much you know about it, so we can again fine tune the rest of our content. So I'll let you answer that question. It should be in the polls that I just published anyway. So I see some of you already begun answering that question. I'll let some more people answer because I think we're still waiting for quite a few responses. So far, it seems like there's a lot of people that have basic knowledge of it, which is good. More than 50% so far say they have basic knowledge of the technology, which is good. Good to know that. Okay, all right, let's keep going. All right, so what is database? I'm going to do a little bit of a deeper dive into database and memory. Of course, the remaining speakers will talk more about it, but I'll try to go through this quickly in the spirit of staying on time. Database in memory is based on a new in-memory column format. It's stored completely in memory with no disk format changes, which means that there's no upgrade impact, there's no compatibility impact. It's available on all platforms, and most importantly, all the features of the database, the time-tested, battle-hardened Oracle Enterprise features like RAC and advanced security, max availability architecture, they all work transparently with database in memory. You do not have to keep the entire database in memory. It can be enabled at any subset you wish. You can put the whole database in memory if you want, but you can put table spaces, tables, partitions, or sub-partition memory, depending on what data is hot. This is very important because in most databases, you don't want the whole database in memory because you're really querying only a small part of the database at any given time. There is the Donald Knuth law of, I think, 90-10, that 90% of the time applications spent in 10% of the data. You can fine tune and target that 10% creatively to make the best use of your available memory. In-memory is fast because of a technology called SIMD vector processing. This actually is not really a new technology. SIMD vector instructions existed since the 70s in specialized vector machines, but now they've become mainstream in almost every single chip because of computer graphics and machine learning and so on. The way SIMD works is it allows the chip to process multiple values in one instruction. So if I'm doing a compare of multiple values, I can do that in one cycle. So look for all the values in the column that match California. I can do that in one cycle. And this is one of the big reasons that we can get billions of rows per second scan speeds with in-memory columnar. Whereas no matter how fast your row format, you can't get to more than a few million rows per second scan speed. So you can literally get 100x to 1000x speed up using in-memory columnar processing for these type of aggregation queries. There's many different technologies underlying the column store that enable this. So just the act of keeping the data in column format gives you performance benefits because you access only the columns you need, not the things you do not need. So just the state column or the sales column, you can skip looking at anything else. I mentioned SIMD giving you multiple values in one instruction. The in-memory column store also has storage indexes, which basically tell you which sections of the column store you can skip looking for a certain value. So in this example, if I'm looking for, say, the value 9, I know that I can skip the units at the top two units, and look only at the last unit. Imagine the column store, is divided in these units of column representation. Each of these units has a min and a max value that tell you, which units to skip when looking for a certain value. And of course, everything in the column store is compressed. So that also gives us both a performance benefit as well as a space benefit. Performance because I have to look at less memory and consume less memory bandwidth to process a certain amount of data. So this speeds up every aspect of analytic query processing. It makes scans faster because I basically scan and filter only the columns I need using vector instructions. I'm not going to go into details about this stuff, but the same idea, because scans become so much faster, a scan can really replace an index lookup. And this can be used over and over again to make joins faster. We can scan and filter the large table first to look for values that match the small tables. If I'm looking for sales of a certain type of product, I can basically do a very quick scan of the sales table and eliminate disqualifying sales rows before the join is processed. So this gives you much faster joins as well. And the same idea can be used for reporting, that if I'm looking for a report that involves multiple dimensions, I can create an outline and rapidly exclude elements from the fact table that do not match the outline and run complex reports much, much faster. So again, there's a lot of detail I'm not going to go into here, but you can look all of this up. And some of this, I think, will be covered by Shashank and Andy later on. This last trick we call in-memory reporting is actually known as vector group by. It's a very nice trick, but again, it's all based on the same fundamental concept that your scan at the rate of billions of rows per second is so fast that you can use that to replace any index lookups you might have had in the past to retrieve your data for analytic purposes. Now, I've so far talked about analytics. What about the transactions? Like Megacart is really what we call a mixed workload. It's not a homogeneous analytic application. It's a workload that has transactions and analytics. Now, in most workloads where I have these analytic indexes, as I mentioned earlier, index maintenance is expensive. And you only get fast analytics on the columns that you index, and they make the database bigger. You can, with the in-memory column store, you can replace all these indexes with the column store. Now, the column store is in-memory only, so updating it or maintaining it is fast. Any column that you want to query, you get fast response times for. It's like indexing every single column for analytics. And not having analytic indexes also makes your database smaller. So you get a more efficient, simpler architecture using the in-memory column store. Now, we don't stop there. What about the case where your database does not fit in memory, right? And I have very large tables I also need to scan. On Exadata, which is our flagship database platform machine, we have pushed the in-memory column format into the Exadata Smart columnar flash cache. Effectively, what it does, it extends the in-memory from the DRAM in DB in the compute servers to the flash in storage servers with the same optimizations. Everything I mentioned earlier with storage indexes, vector processing, vector group by, they all exist also now in the storage servers. The result is you have a huge increase in the effective capacity of your column store. Half a petabyte potentially on the full rack X8 machine. So this can be used for large tables that you can't fit in DRAM if you want to run gigantic analytic reports on them. You can push them down to Exadata storage using Smart Query Offload instead of having to create a separate reporting database. So it's much better to have one database in which you can run your entire workload than creating a second database with the transformation. Your reports can now run really on the flash extended in-memory column store. Database in memory is technology we're very proud of in the Oracle database. It's one of our headlines for each new release. We've done every release, we've made it better. We released it, it's actually been a while now. 2014, I think, was when we released in memory in 12.1. But as you can see from this trend line, every release has added significant functionality. And the 21C is the release we're currently going to get out to you very soon, on premise at least. It's available in a limited form now on the cloud, but it's going to be available on premises soon. This will have a lot more innovation. It'll have fully self-managing memory. It's lots of extensions for other types of workloads as well, not just traditional analytic workloads. So very, very cool technology, lots of development behind it. Speaking of 21C, we are, again, Oracle Database's mission right now is to support all workloads. We have this converged database sort of philosophy that you don't want multiple databases to solve different problems. You want one database. So converged analytics with spatial and text, allow much faster joins with in-memory vector joins, allow hybrid in-memory scans so that if I have data that is partially in the buffer cache, partially in the column store, I can get really good performance, and as well as self-managing in memory, where my database automatically figures out what to keep in the column store, what to evict. So there's no need to even declare tables in memory, that this technology will be able to detect candidates automatically based on available space in the column store. So this is not a poll question. So the question is, whose technology is the best amongst all the in-memory vendors? And of course, there's one obvious answer here. It is Oracle. And it's not because I say so. I might be biased. You'd be right to say that I'm biased. I'm not the right person to judge this. But analysts say this, it's not us. So Forrester did its first in-memory wave a couple of years ago, a few years back in 2017, and Oracle rated highest for in-memory technology at that time. Since then, they did a second wave in 2019, where they rated translytical platforms. They said, well, in-memory is table stakes. What really matters is translytical data sets, which workloads, which have which have analytics and OLTP, and you need in-memory for that to be possible. So they like the fact that we have this dual format architecture, and again, rated us as #1 with translytical workload support. So Oracle was the leader again in this wave. Since then, apart from Forrester, Gartner ranked us highest for, a use case that requires in-memory. They call it augmented transactions, where again, it's basically mixed workloads with real-time analytics. So in 2019, they ranked us highest for augmented transactions on the strength of in-memory. And last year, they ranked us highest again for augmented transactions. Last year was the first year that they switched to an all-cloud view of databases. So even for the all-cloud view of the world, they ranked Oracle Database highest for autonomous database, augmented transactions, because it makes use of in-memory columnar processing. In-memory, like Ranjan also mentioned, as I said in the abstract, it's not just simply about speed. It is such a massive boost in speed. It does fundamentally more. If you think about the the world before air travel, I don't know that world. I wasn't born then, but I can imagine things very different then. It would take multiple days to cross the Atlantic. I don't think the fastest Atlantic crossing was any faster than at least 4 or 5 days. Being able to travel across the Atlantic in hours made a gigantic difference, to society. It changed almost every aspect of society. It changed business, trade, politics, education, etc. Everything was affected by air travel. So likewise, database in memory does not just make things faster. Your instant business results, instant decision making allows it to be far more responsive to changes. Not requiring additional systems for reporting means that you have much lower cost. And essentially what you get to is a much simpler overall architecture. So it's fundamentally makes the enterprise a lot more efficient. And in the case of this megacard application with in-memory, you can run everything on the same database. You have your in-memory column store, the in-flash column store for the longer-term reports, in-memory reporting. You no longer need to have pre-computed summaries and analytic indexes and a separate data warehouse with a star schema. All of that can be run on one single converged database, no reporting database. You may still need a data warehouse if you're bringing in data from multiple sources. That's a different problem. But in terms of running a business based on the live actions on one database, you can still use that single database to run everything. So you get much simpler, much more well-orchestrated enterprise architectures using in-memory. Lots of great use cases for in-memory. I'm not going to go through this in much detail. I think I'm running low on time anyway. Lufthansa is one of my favorite use cases. I mean, I like all of them, but Lufthansa is one of my personal favorites because I like traveling. And every time I travel to Frankfurt and I see the gigantic aircraft hangars that are used for aircraft maintenance, I'm very happy that in-memory is used actually to make aircraft maintenance operations much, much more efficient. So they use in-memory technologies to speed up the process of identifying which airplane parts need refurbishment when an aircraft goes in for a, I think every 6 years, aircrafts have to go in through these major refurbishment cycles. So apparently they use in-memory to speed the process up significantly. So if you travel to Frankfurt again when the pandemic ends, if you see that gigantic hangar, you'll know that we're hard at work inside that operation. A lot of these use cases, you'll see it's not just about speed. Yeah, things become faster, but in many cases, you'll find that the database is also becoming smaller. It simplified the application because it was able to, essentially get acceleration without having to add new databases or new modules or indexes. So you can see that, many mixed workloads became faster without any application changes required by adopting in-memory. My last poll of the day is, I'd like to know what help we can give you to make better use of in-memory, of database in-memory. Assuming you want to eventually get to database in-memory or some in-memory technology, what would you like us to help you with? Many of you I know are still on older releases, like 11.2, for instance. That we can't help you with. That you got to help yourself with to get to 19C and beyond. But do you need help with more technology details? Do you need help identifying use cases? Would you like help in identifying what data to keep in the column store? Or are you perfectly happy? Are you a happy camper? Either way, please let us know. This is the final poll that I think has already been answered by several of you. I'll take a look at the answers later on. Again, I just wanted to conclude by just giving you a quick sort of sermon on complexity. There are basically 5 stages of complexity, 5 stages that get you to this point. And I've seen this happen, so this is not completely made up. The first stage is denial. People look at that and say, well, that's actually quite simple. It looks complex to you because you're not an expert. But I understand that because I've been here for a while and this is very simple. So that's called denial. The second phase is pain. That no matter what happens, this thing eventually will break. And then when it breaks, it's incredibly painful to fix. So from denial, there's like suffering is the next step. After that, it's anxiety because the excruciating pain of fixing this is replaced by this uneasy sort of calm before the next outage happens. So when is it going to break next? You really can't relax. And then, of course, it breaks again. And eventually this happens enough that depression sets in, that it's always going to break. So, my life is horrible. It never gets better. The system is really unmanageable. It'll always break. And now I'll be called in or paged in the middle of the night to fix it. And I haven't seen this happen personally, but I can imagine if this continues long enough, it'll lead to substance abuse. If this perpetuates, depression perpetuates, people like to find other escapes from depression. So it's a possibility, hypothetically, to lead to much more serious consequences. So my advice is, please just say no to complexity. There's a saying that simplicity is complexity resolved. Go for simplicity more than anything else. Try to simplify your architecture, reduce moving parts, reduce friction between components, and get to the point where your system runs best with the fewest number of components, because that's really the heart of getting a scalable, robust infrastructure. Please feel free to reach out to any of us if you have questions. So Shailendra, Ranjan, and Andy are product managers for the technology. The development VP is Shashank Chavan, he'll be talking today as well, and so will Andy, actually. So if you wish to take a screenshot of this, please go ahead and feel free to email them with questions if you have any. If you wanted to get started with in-memory, Oracle Express includes in-memory up to 2 gigabytes, I believe. It's available, and I've created some short links for you for convenience, and you can hopefully go there and just click on that, and you can go get an Express download with a small column store that you can bring up. 19.8 onwards, the in-memory feature is available for free as part of the base level. So in-memory is a paid option, but up to 16 gigabytes per instance is available for free with the new base level feature from database 19.8 onwards. So if you have 19.8 release update onwards, you can try out in-memory, and there's no charge for it. You can even deploy it in production with this column store less than 16 gigabytes. It's a good way to get started, and it's a good way to kick the tires. And for many use cases, that's sufficient for many workloads, because you just want to keep some hot reference tables in memory, you can just do that with this small column store. And yeah, we have a very active in-memory blog for the most recent announcements. There's a very nice detailed overview of the technology in a technical brief that's also available here. And of course, everyone should try out Autonomous Database for free. I mean, Autonomous Database is a way to try out every Oracle technology there is. You can't try in-memory out explicitly. It's done for you underneath, but it's a great way to look at Oracle's converged capabilities. Try out all the Oracle features for different workload types, different data types, and so on. And I think I've overstayed my welcome, so I'm going to stop sharing and hand that over back to Ranjan so that he can introduce the next speaker.
Yes, thank you, Tirthankar. That was very insightful. So with that, let's bring the second keynote speaker onto stage. He's Rich Niemiec, and his topic is leverage technology and use in-memory for acceleration. Rich Niemiec is the current CIO for Viscosity NA. He is an Oracle ACE director and former CEO of Tusk for over 20 years. Rich is past president of International Oracle Users Group and in the Chicago and EY National Entrepreneur Hall of Fame. Creating the future will depend on the speed and the security of the database. Oracle's ability to leverage big data and IoT using technology, including machine learning and AI, make in-memory a crucial benefit for performance. This session will look at how to leverage Oracle and use in-memory for speed. Rich, stage is all yours.
And can you hear me okay and see my screen? I might ask first.
I think if you can be a little louder, it will be good.
You got it. I'll turn up the volume. So first of all, I want to say, hey, it is the most exciting time to work in the Oracle world. I think Tirthankar covered very well what it took decades to build and leverage, not even including the security side of Oracle and the analytics I've seen since the 90s being built. So this is an incredible time to be here. As they said, I'm going to cover, as Ranjan says, I'll cover how do we leverage technology and what does in-memory do for us as we leverage technology. And I give this often to CIOs, CEOs, CFOs, different parts of it at least. But also I want to look at, how they've had it since 12.102. You can do it on premise. I saw a question on that. They have it now. And what they're doing in 19 and 20. And you should try to be on 19C. Somebody asked me today, what version should I be on? It should be 19C. There's a little bit about me. I'm not going to cover a lot of it. I'm the person on the right here. I'm not the guy in the middle. But I've written a lot of books and I've seen the depth of the Oracle product. And this is a time, especially with things like machine learning coming, where Oracle is really, really, really going to shine. And people that manage the data are going to be very important. I work for a company that not just does Oracle, but it does infrastructure on AWS and Azure. But Oracle really shines when it comes to in-memory and Exadata. We also do apps data. But I want to look at more of what's important now. I always say, if you want to win, Lou Holtz used to say, if you want to win, remember the acronym WIN, W-I-N. What's important right now? I think what's important now is to start to leverage technology and ensure you have the performance that's going to be needed for all these different data types in the future. And then what I like about this, what's innovative with Oracle and how in-memory advances everything that you're going to be putting into the database, like big data, IoT, machine learning, whether you use Oracle applications, chatbots, robotics, all these things are going to be the key to prepare for the future. If we look at Oracle, first I say know the Oracle. In 1995, they had a 64-bit database. That means if the hardware was there, you could, in memory, address 16 exabytes, 16 million terabytes of data. They right now currently have a 5 petabyte database you could go set up in the cloud if you wanted. But what did Oracle do? Because there wasn't the hardware, they bought a hardware company. And then they started accelerating the world of hardware all of a sudden. Then they bought applications where that extended to. Now they're buying machine learning companies, and they're going faster and faster so that you can leverage technology. You don't need to rebuild all this. It's already there. Last time we met in person, San Francisco, this is the busiest street in San Francisco, Howard Street. They block it off because Oracle can't fit in the convention centers with all the people. The appreciation event at a baseball stadium, just amazing. But we're moving from this mainframe world from 50 years ago to using digital, where the computer is in our hand, to wearing it, to implanting it, to the hive mind. How do we serve that up in a fast enough way? But also look at, when I look at the C-level, they are being disrupted. They see things being disrupted. Look at the disruptive innovation. Postal mail went to email. Floppy drive went to a USB. Encyclopedia to Wikipedia. Filing cabinet became a database. Now email is going faster. Text, Snapchat, Instagram, Wikipedia is Alexa and Siri answering the question. And the DBA can no longer manage all those databases. So you have autonomous database to help manage some of those. But innovation is more than tech. What does an innovative company look like? Well, they understand the current technology has passed, maybe a telephone, and the emerging technology, a cell phone is what's there. And they leverage things like big data, chatbots, robots, AI, IoT. Are you doing that right now? Somebody like Apple, always a tech innovator. What kind of innovation do you do? They're a tech innovator. How about Amazon? They're a retail innovator. You know, they have their own Black Friday, Prime Day, Innovation Day. How about Google, a marketing innovator? They do also leverage data, though, with autonomous cars, things like TensorFlow, where if I look at 1,000 images of cats, I can say, hey, if you see a cat, it automatically recognizes it. And then I say, if you see a cat on the road, don't hit it. They use that with TensorFlow, which, oh, by the way, is integrated with Oracle as well. What's Oracle's focus? Oracle's focus is make you the hero at your company. Make it so you are the best marketer. You're the best retailer. Leverage, giving you just the tools that make you great. Oracle's all in on the cloud and machine learning. You know, last Q4, Oracle grew 140% in the cloud. Oracle bought a company called datascience.com, and they're focusing on how data science and machine learning is going to give you competitive advantage. But the real competitive advantage is all the things you just saw Tirthankar show. How Oracle is put in partitioning and in memory early, ages ago in some ways, 12.102. A robot may not look like one, though. They never complain. Robots that manage a database. Robots that do machine learning and AI. Managing, self-securing, self-tuning, self-recovering, self-scaling, self-patching. Before you even know there's a patch, they put it on. I'm the DBA. Am I worried about that? No, I don't want to be that telephone operator trying to keep my job. I want to leverage the technology that's out there. Make sure you're where the innovation is. The data is critical. If I'm a DBA, serving up the right data, gathering the data, being a data administrator of all data is critical right now. And I just hit the wrong button then. I went to the end. I'm very sorry for that. Getting overexcited. I hit the end. Hey, in case you wanted a quick review, here it is. All right. So is it time for workers to worry about AI? And the answer is, I think so, if you're in some aspects of work, but not if you're a database administrator. Because if you know Oracle in this diagram, you know 90% of the diagram. Hadoop is like learning a feature of Oracle. I can go through Big Data SQL and make Hadoop secure, or go through it to go to some other NoSQL database. Data is becoming very important, though. The in-memory column store, these examples just FYI, I'm not going to teach you anything, but the in-memory area, it shows you how much it is. We talked about how the row used to be very important. It was in the buffer cache. Now the column is in the in-memory cache for different types of transactions. Make sure you segment it in those ways in your system, but also with queries. A guy that wrote the best-selling tuning book, as that person, I found that, when I'm doing row level, it's fast. But if I use this and it goes to all of these, it's very slow for this query. So what do I do? What if I had those columns separated? Oh, now how small can they compress these N's and Y's? The answer, very small. And it's unbelievably fast to do this query now. So for better performance. And somebody asked how to set it. There you go. There's an example of how to set it. I'm not going to go through it just so it would be in the slides. I wanted to let you know it's there. Tirthankar talked a lot about this, but it's column data, could be compressed. It is compressed rather. They use storage indexes internally to prune it. If you create your own indexes, it's not as good because the storage indexes are also in memory, something that they leveraged from how they did Exadata. And then they also use SIMD, which Tirthankar covered well, but I always look at it and I go, this is what gaming does. I have 40 million users using League of Legends. If you've ever heard of that, I use SIMD. What is in memory at? You can see all the different levels that I can put it at, table space, partition level. How hard is it? What I love about it is all I do is add in memory to create table or alter it in memory. I do need to populate it, force a full table scan or populate. You'll see in the future, Oracle has a way to do that automatically. Running queries doing in memory. I always do auto trace, make sure it's using it. Make sure you understand it well enough that it is using it. And I could set different compression levels for some things. And then I can say no in memory for some columns. Isn't that nice? And then there's hints that I can set. If I want to turn something off, something's not working. But in simple, it's part of the SGA. There's the buffer cache, all my data, shared pool, all my statements, and the in-memory area now to look at columns in a compressed way. And they talked about in-memory compression units is where I put that table data. And then also you were going to see in-memory expression units in a second with virtual columns, things like JSON. But I look at Oracle, they're also putting machine learning in the product. Adaptive query optimization. You run a query and the optimizer starts running it with a nested loops and it starts looping through and it says, whoa, you've run through this too much. Your statistics have not been collected. Let's change this to a hash join to be faster. So they change it to a hash join. So when you look at everything in Oracle is becoming faster in memory joins. Just create a join group to put that. And those columns shared a compression dictionary. Faster in memory for big data, we'll see. So currently, if I want to go to things in a secure way to other data types, I can go through Oracle with big data SQL, but now I can actually partition that data as of 12.2, and that's why I have this logo here. And then in 19 and 18C, now I'm going to start leveraging in-memory external tables as well, and support for Hive and big data drivers. So things like Hadoop and Hive, which weren't that fast, I can now put them all in memory using Oracle and going through this secure Oracle portal to get there. And all I have to add is the word in memory. Wasn't that nice? Oh, but if you have JSON, I mean, I could use a document database and have a whole separate database, hire a whole different staff. Mongo Apocalypse comes to mind, but I could just use it in Oracle right now. And you can see virtual columns from JSON objects loaded into memory. And I forgot to say, and that's where the in-memory expression units come in. Tirthankar covered this well, but I did want to say something he didn't say that I think is even more critical, and really the sense of what he was trying to say is converged database, 10 times faster, spatial analytics, 3 times faster, text analytics. Oh, and I get to go to them in the same database. SIMD, maybe 10 times faster, could be even faster than that. In memory, hybrid scans 10 times faster. You're multiplying all these things. Then partitioning might be 1,000 times faster. So you're getting millions of times faster. So now you're getting to those billions of rows per second. And oh, as I said, I'm going to do an automatic in memory to populate, to evict things. No need to do that anymore, to declare it. And you can go to the docs. I just wanted to have a link here if you download this so you can read more about in-memory scans or automatic in-memory. If I set it to high, you can see it actually does compression as well and does a hot, medium, cool here Very fantastic. I think this is one of Tirthankar's images. Then Oracle said, you know what? Not enough people are using this. You have no idea how important this is in the future. We're going to give you 16 gigs for free. Start to try this out. Oh, we're going to backport it to 19.8. Now, it doesn't give you that automatic in memory, unfortunately. You have to buy that part. But hey, now I have a base level. And you can go to the docs. Very easy here. Click on what's new, go to database features and licenses, and you can read more about it. Different database in memory enhancements for the base level. Very nice. Or you can look at licensing as well. And then in 21C, Tirthankar talked about all the new things. These are things you're going to need in memory for too. In database JavaScript, I'm going to put more of that in the database. JSON, so that I don't have to get a whole new database for documents. AutoML, automatically do machine learning. I'm going to show you a very short example. Multi-tenant database to separate things, but also you had that since 12, but now you have multi-tenant data guard. Native blockchain tables, as we look at things where, you know, you might want to use blockchain. Persistent memory. Maybe I want to put my whole database into Optane. Multi-tenant security and the security side. When you look at Exadata and how amazing it was, and I thought it was quite amazing when Tirthankar said we could put half a petabyte. Now on the exabyte side, Exadata side, if we needed it. But look at all the features. Start adding up the multiplication. You get multi-tenants separating people from each other. In-memory database. Real application cluster. One node goes down, the others are up. Data guard to move it over. You can actually now do DML on the other side of data guard as well in certain versions. Partitioning, compression. These are things that are speeding things up. Storage indexes in Exadata, and then also those indexes in memory. But the big feature is this one. Security, which Oracle's been doing for almost 50 years. So when you look at it, we're doing for over 50 years. But when you look at it, some database people will tell me, well, we have that security just like Oracle, and they'll pick one of these things. These are things built over decades, and many of them take decades to get right and do well. You're the last line of defense out there. Is your database protected? Protect people from themselves, or you'll draw their mistrust later. Don't make it go from magical to manic to toxic, or you're going to be a company that's going to be easy for somebody to replace. If we look at big data, as we expand maybe what database we have right now, it's very big, but it's also coming at us very fast. The values of different data is different. There's an incredible variety. The veracity, the truth of different data is very different. So a relational database becomes very important. But more importantly is that I can go to all those different data types with a converged database, whether it's relational, whether it's a document database, graph, spatial, JSON, whether I want to use Python. When you look at Oracle's machine learning, you're going to see they use Python, SQL, R, whatever you know, it's in there. So I don't have to do that. I don't have to integrate it. Oh, and a lot of this stuff is free. Spatial, text, Java, OLAP, JSON, 16 gigs of in-memory, 3 free multi-tenants, backported for you for 19. Data is becoming the world's most valuable resource. Database people have to start leveraging this for their company with this disruption that's happening in this world. Oracle is the place to do it. IoT is going to give you even more data. Are you connected into those things now? How about the consumer? Are you connected into those things? I mean, here's a refrigerator that says, you know, we're connected with your bathroom scale. And if you don't start eating some of these foods, you know, we're going to have to lock the refrigerator on you maybe. We're going to where we used to look at as a CEO, what happened? And it was why did it happen? Then predictive analytics, what's going to happen? Am I going to make my quarter? Now it's prescriptive analytics. What's the best thing that can happen? Prescribe it using machine learning. And then inside of Oracle apps, Oracle has also added machine learning. Took somebody from the apps part and the machine learning people, put them together and look at all the apps that have machine learning built into them. And just an example of manufacturing. You may see a warning with your supply chain here: quality, yield, cycle time, product returns. And what are the issues here? Built into the app. How about the workforce? Who's very important and who's going to leave? How soon are they going to leave as the market heats up? Why are they leaving? When's the last time I gave them more vacation or more pay? And then what if? Hey, what if I gave them more pay? Oh, they're still leaving. Oh, what if I gave them a week more vacation? Well, that means a lot to them, so they'll stay. Oracle has built machine learning into the product, but without in-memory, you can't make it fast. Billions of rows per second matter with machine learning a lot. Machine learning, what do? First, what's my business problem? I want to know my good and bad customers. Maybe I want to classify them into those. Then what do I use? I'll use classification, and then I'll use an algorithm to do that, one of the classification algorithms. Oracle has them all built in now. You can see all the different ones that are out here. Then you can build the model with 60% of your data and train it with that data, and then test it with the other 40%. You also can compare algorithms. You're going to see with Oracle Auto Machine Learning, it'll do some of this for you. But how many does Oracle have? All these different business functions and functional areas that you need, you can see. Good and bad customers, classify them with multiple algorithms. Which one is the fastest? Guess what? Oracle will test them for me. Clustering data, maybe clustering big data into age groups because a certain age group buys my product. Anomaly detection, who do I have to worry about right now? Time series, when are my sales? Or maybe seasonal. Regression, am I going to hit my numbers? Attribute importance, what makes these my best customers? What are the attributes? Association rules, what do people buy together? And then all these predictive queries, SQL analytics, and statistical functions that Oracle has been putting into the product for 40 years, you can now leverage those within machine learning where you're going through billions of rows. Then there's also a few others, feature extraction, text mining. And again, as I said earlier, R, Python, also in there. If you've never done machine learning, I decided I'm going to give you a quick example. These are all the people in a circle. Mathematicians over a decade, well, decades of time, built math that made it better and better and better and make the circle smaller, smaller, smaller till the outliers are out here to find anomalies. Now I can leverage that through an algorithm. Oh, these are my good and bad customers. Separate it not by the green line, not by the blue line, but the red line, so they're as far as possible so that when I go to big data, I know which side of the line they're on. Are they a customer that's good or bad? And then how hard is it? Oh, if your staff already knows SQL and PL SQL, well, guess what? Then I could do machine learning. And here I'm calling an algorithm, in this case, a decision tree. This is the select based on the customer. Will they buy my credit card? And I'm maybe training my data. Then I'm going to look, see the probability of big data. Are they going to buy it? Give me the most likely ones. Maybe I'll pass that to the salespeople. Wouldn't that make life easier? Oh, not fast enough for you? Well, guess what? I've done this before, and then all of a sudden auto machine learning came out after writing notebooks, they're called. But now Oracle takes the data in 21C, does automatic algorithm selection, adaptive sampling, looks at the data even for me, denoises the data for me, tunes the model, finds the best algorithm for me. I did this on something that took me a day, maybe even 2 days, almost 2 days to build. And I said, I'm going to try this auto ML. 2 days, let's see how long it takes them. And I said, hey, I want to classify some data, but I use multiple algorithms. So I tested all kinds of algorithms. I want to predict, is the customer going to buy this credit card? I could do faster results or better accuracy. And it started running. And you could see all the different algorithms if you're a machine learning, but 5 different ones had tested. Then it said, oh, do you want to create a notebook too? Bam, created a Python notebook for me in 4 minutes, something that took me 2 days. I was like, wow, what am I going to do now? And there's my notebook. I'm going to leverage it is what I'm going to do. So are you leveraging the parts? Are you using machine learning? Supervised learning means I have the data. Oh, I have images of cats. Do image classification so I don't hit it with my autonomous cart, or classify that data for fraud detection, or use that data to show me what the forecast is for my product or even the weather, or go to big data, unsupervised. I don't have the data. Go cluster that data into targeted marketing that I could do on the segment that I already found that my good customers are. Or just use machine learning for fun. This is a guy that said, hey, I'm going to take paintings. You know, there's Marie Antoinette and Henry VIII and Queen Elizabeth. And what would they look like if you saw them walking down the street? And here's a snack cake, Little Deb's, and she never existed. So what would she look like if she did? We're going into this place that's a twilight zone. And the reason why Oracle had 25 years ago this 64-bit database where I could address directly 16 exabytes of information, or 18 with 18 zeros. It's like moving from Windows 1 mile an hour to 32-bit was like 65,000 miles an hour. And you're like, wow, the internet, that I felt that. But now we're jumping to 64-bit. It's 300 trillions of miles an hour if I put it using these numbers above. We're going into robotics, machine learning. What's going to make those things faster? In memory, of course. What didn't we have way back when Oracle had a 64-bit database? Fast enough hardware and in memory. Gartner looks at it this way. These are products kind of coming, and right about here, less than 5% adoption, and then out here, 30% adoption. So let's take a look back in time, because you were there. 2013, it was all about tech. Big data is coming. Autonomous vehicles are coming. Cloud computing is coming. And all of a sudden, 2015, it changed what was on this graph. It's all about robotics. And connected home was coming. Smart robots. Autonomous vehicles still were coming. Hybrid cloud computing was coming. Then 2018, all about robotics. Digital twin. Maybe that's you and your autonomous database DBA. Brain-computer interface. Connected home. Very close. Augmented reality. So you can see now many of those things are here. But what's coming now? Machine learning. They go through, if you ever use TensorFlow, you might look at billions of images, and you find that you go through this data multiple times to see patterns sometimes. You might go through billions of rows, multiple epochs. So when you go through that, I mean, you're looking at maybe 100 billion rows that you're going through. How important is in-memory going to be for machine learning? And then extend that even further. I'm going to put that exadata eventually into that robot and all that machine learning into there so they can assist me like they do currently with my autonomous database, because I'm managing too many databases maybe. But do you want to be that future innovative company? Do you want to be that future innovative person? Well, leverage a database, GPS, robotics. You saw how Oracle also is leveraged into geography, spatial data, and things like that. This is a robot that pours a cup of coffee for you. Robotic process automation. 85% of business processes can be automated. Machine learning makes it easy to do that. This is a company called eAlliance. It does all this now. But basically what it's doing is just doing all those steps, a step at a time, and then letting the robot replace you so that you could do other things. Are you leveraging the database with virtual reality, with mixed reality, augmented reality? You can see different ways whether it's through an iPad or through it's with virtual reality in different ways. Oracle has this currently working. Are you leveraging it? Are you leveraging Oracle with TensorFlow, with machine learning? It's available right now. AL, as I said, they have it embedded in the apps. They also have it embedded with IoT and also chatbots and things like that. And you can see some augmented reality as well here. I look at the world now, and you saw the Star Trek Enterprise when Tirthankar started to speak, and I thought that was interesting because I have it right at the end. And I look, when I was younger and I saw Star Trek and the communicators and all those, and I thought, wow, it might take 1,000 years for us to get there. We're past it already. We're past this technology already. And we're moving to this where people are transcending biology. I mean, you think of Edward Scissorhands, this guy already uses his arm for his job. How amazing is that? That's out there. So what do I think is important now? First of all, know the Oracle. It's had 64-bit database 25 years ago. If you're a DBA, you're an important person because you need to access and manage all that data so it's secure, coming through a secure Oracle portal, and you're using things like in-memory to make it fast. And then how critical, I wanted to show, in-memory is for speed at this time in history. We're going to be going through billions of rows with machine learning or chatbots or robots or with Oracle applications so that you could predict your future numbers for the coming quarter and preparing for the future. And hopefully you're on 19C now. If not, we can help you. If you want a copy of this, you can always send it, just write to me, richiemiec@gmail. I'll get it. But I look at, you make a living by what you get. You make a life by what you give. I look at Oracle, they've given a lot to the world. A few great ones, Dr. DBA, Joel Coleman. Joel Coleman built this huge Apex world because he wanted to make a difference in the world and all the amazing things people were doing with Apex. You should be doing amazing things with this Oracle database. And that's Mark Benioff. You don't see Larry and Mark Benioff, but this is where Larry won an award for the Ellison Medicine Center where they leverage machine learning. Put that in memory. And then Yoshiki, great music, we'll add there. Oracle, great sales and marketing, app leader already. BI, they've done for 30 years. People are building companies and they're trying to do the same thing. And they're going to have this auto machine learning advantage in the future. Cloud, they are starting to grow triple digits percentages. I think they're going to do well. A few books I've written, try to get them from these Oracle aces. I always look at this graph too. This is a graph of top database. If you stretch this back to 1977, Oracle was #1. And I used to show it all the time. And they're still #1. Other things kind of go up or down. I mean, some things come on that are new, maybe Snowflake, Google coming up a little, but I'll tell you, even Cloudera came up for a while and then leveled off, but Oracle continues to be #1. So make sure you take the time to learn all these great things that are out there. Things may come to those who wait, but only the things left by those who hustle. Thank you. And I'll put it back to Ranjan.
Yeah, thank you, Rich. I liked what you said, that in-memory is your secret weapon for performance. And he also said about, hey, if you want to be future innovative company or future innovative person, you need to rely on machine learning and database in-memory and so forth. So thank you so much, Rich. With that, we go into the technology champions. The next speaker is Shashank Chavan. Shashank, you can get started with setup and all. So his topic is what's new in database in memory. Okay, Shashank is the Vice President of Database and Data and In-Memory Technologies Group at Oracle. He leads an amazing team of brilliant engineers in the database organization who develop customer-facing performance-critical features for an in-memory columnar store. Our database, Oracle database in-memory team is constantly innovating and adding new features to the product to best meet the demands of real-time enterprise companies of today and tomorrow. In this session, Shashank will cover a broad overview of new technology we have developed for our database in memory. Shashank, stage is yours.
Okay, great. Thank you for the introduction here. So the title of my presentation here is, Oracle Database in Memory, Technology Designed with Tomorrow in Mind. And the goal of this presentation, as Ranjan said, is to talk about the new features that have come out within memory, but really express them or describe them in terms of the foundational set of features that we've always had since in-memory came out, 6 years ago. And so that's why it's called technology designed with tomorrow in mind. The features that we developed back then are our foundational sets that allows us to build features today. So you've all seen this slide now thanks to the great presentations by Rich and Tirthankar. This is our dual format architecture. And why I'm showing this is I really want to describe 3 key design requirements that were laid out when we were first developing in memory. The first is that we needed to improve both analytic and mixed workload performance by orders of magnitude and have negligible impact to OLTP workloads. That was a requirement for us. And our dual format architecture allows us to have that by keeping the data both in the column store and, as always, in the row store. The optimizer can choose which of these 2 to go to and get very fast performance on the column store for analytics and very fast performance for mixed workloads going to the buffer cache. The second thing is the row and the column stores must be simultaneously active and transactionally consistent. And so I'm going to show you another slide going forward about how we developed this requirement, designed it in the architecture, and then built into it additional features that allows us to really make mixed workload performance run very fast without impacting our analytic performance. And the last one that's very important is it has to be seamless to use with native integration to existing and future Oracle RDBMS features. So all of our features that we've developed, over the past 30, 40 years, partitioning, rack, sharding, all of these features have to continue working within memory. So we didn't want to build a separate storage or query processing engine just for making analytics run faster. It had to work with all of our existing technologies today. So these are what I call our foundational features or foundational set or core features of the Oracle database in memory architecture. And we designed these, like I said, from day one. And from that, we're able to build on top of it more extensive analytic features or more extensive mixed workload features on top of the column star. And so that's what we're going to discuss today. Okay, so as part of this, describing what are these foundational set of features, this is sort of a deep dive, a little bit of a deep dive into how we store our data in memory. So we store our rows in these compression units called IMCUs, or in-memory compression units. And each IMCU normally has about 500,000 to 1 million rows, and it keeps all the columns of that table in the IMCUs. You can selectively choose which columns you want in memory. You can selectively choose which partitions you want in memory. You have a lot of options to you. But by default, you'll have all of the columns. Okay. Now, a key point here is that the IMCUs are mapped to the rows on disk. So if you see on the bottom here, extents with blocks 20 to 120, extent number 14, blocks 82 to 182. There's a direct mapping from the rows on disk to their location in memory. And that's very important because that will allow us, as we'll see shortly, how we can achieve a transaction processing that will continue to go on like we normally do in the row star without impacting the columnar representation in memory. Okay. This is another slide. Again, it's part of the foundational set of features for in memory, and it's how we make analytics run faster. So our analytics run fast using something called vector processing, which leverages SIMD instructions in modern processors. SIMD stands for single instruction multiple data. You've heard this now a couple of times today. The key idea behind this is that we can process data in parallel with as few instructions and as few cycles as needed. So in this example, here we're trying to find the sales in state of California. We have a column called state, and we only need to access that column. So immediately we see the benefit within memory column store because we only touch the columns that are needed to be accessed. and we can load them into a SIMD register, which is a very wide CPU register. And in this example, imagine loading 64 states all in one cycle, one instruction. And then again, in one other cycle, you can compare those 64 states to California. And immediately, again, in one cycle, get a result of which of those 64 states actually equals to California. So in this way, we can literally run at billions of rows per second compared to the millions of rows per second that you would run with the traditional row format that we have today. Okay, so vector processing, leveraging SIMD instructions is fundamentally at the core of many of our analytic features that we built on top of in-memory. The other thing is with mixed workloads. So our dual format architecture enables fast mixed workloads and faster analytics. So if you look at the picture on the right again, we have our traditional row format stored on disk or in the buffer cache, and then we have the in-memory column store. Now we're able to achieve fast in-memory DML because invalid rows are logically removed from the column store. We just have to set a bit, and I'm going to demonstrate that in this example next, in this animation. So let's suppose, for example, you modify a row in your table, in the sales table. Okay, that row would get updated on disk in the buffer cache as normal. Nothing changes there. Now, the column store needs to reflect that change. So because of the way that we map the rows on disk to their location in memory in the IMCUs, we can quickly identify that corresponding row in the IMCU and then simply set a bit that says that row is now invalid. That's it. That's all that's needed as far as maintaining consistency here. Now, when you run a query, an analytic query against the column store, what happens is that the invalid row in that column store is ignored. You basically just skip over it, okay? So you process all the valid rows, and just for that one invalid row or n invalid rows, you go to the buffer cache to process them. And again, that's how you maintain transactional consistency between the column store and the row store. Now, of course, as the data in the IMCUs get more and more invalidated, we need to refresh that copy in the column store so that we have valid rows again, so that we don't have to skip these invalid rows and process them separately. And so this goes into how we build on top of that, on top of our architecture, how we can develop features on top of it. So we allow fast background repopulation. We do this by having continuous intelligence to track how dirty an IMCU is and how frequently it is scanned, and then when to take action to refresh or repopulate it. So we have several techniques here, and I'll just really talk about this one. I might skip the other ones, but this is called double buffering. And the idea behind double buffering is when we decide that an IMCU in memory, that block of rows in memory, has gotten really dirty, we will repopulate it in the background. We'll create a new IMCU in the background, and at the same time, keep the old IMCU available for scans to query against it. And once the new IMCU has been populated, we just basically do a switcheroo. The new IMCU replaces the old IMCU, and that old IMCU then gets garbage collected. Okay, so that's double buffering. This allows us to continue querying while we're going through population. Incremental repopulation and column level invalidations are, again, all additional features that we have built over time on top of our architecture so that we can make repopulation as fast and seamless as possible. Okay. Similarly, we've added analytic features on top of our foundational set of features for analytics within memory. In-memory expressions, in-memory join groups, in-memory JSON, in-memory optimized arithmetic. These are just a few of the features that I'm going to describe today in this slide. In-memory expressions is the idea that you are often evaluating or querying expressions involving multiple columns of your table. And computing those expressions can be expensive. So what we do is we can auto-discover those hot expressions and then materialize them in the column store, so that the next time you run that query, in this example, price times tax, we will directly reference it from the column store. No need to recompute them. And so you treat it like a new column. Okay. In-memory join groups is a way to make joins run faster. The idea here is that if you tell us ahead of time that you are going to be joining these two tables with these join columns, then we will format those columns in the column store using some special data formats that will allow us to perform the join as if it was a very fast lookup index, a vectored join, if you will. And so the example here shows, hey, I'm looking for a match with ID 3, and I can just index into this array and find the match, whether it exists or not. Okay, so that's join groups. In-memory JSON allows us to store JSON in the column store in a much more optimized representation, a representation that makes query processing fast, as well as keeps the JSON documents compressed in the column store. We have our own binary representation that's called OSON, and that's what gets stored. We also do very cool things where we can shred the JSON document itself into its separate key value pairs, and conceptually think of each one of those key value pairs stored as a separate column in the column store. So now when you want to say, hey, I want to know if I have any documents that have movie equal to Rogue One, it becomes a very fast columnar SIMD vector processing scan, if you will. Okay, and the last feature here on this slide is in-memory optimized arithmetic. The idea here again is the in-memory column store is almost like our own scratch pad. We can store whatever we want, however we want in the column store. And we leverage that by storing data in more optimized data formats than what exists today in your on-disk formats, in your traditional row store formats. So as an example, Oracle number columns were designed, many years ago to be space friendly, right? It saves on space. They're variable width types, and extremely portable. But at the cost of query execution against those Oracle numbers is very expensive. And so what we can do in the column store is represent these Oracle numbers in a binary representation. And not just, we have something called a decimal scaled binary representation. But the bottom line is now when you do something like an arithmetic operation, imagine a group by sum or just a simple add, we're now doing single cycle binary arithmetic operations as opposed to double-digit cycles variable width software implemented arithmetic operations. Okay, so all of these features again are built on top of our architecture where we use very smart, highly compressed columnar data formats. We leverage SIMD vector processing techniques, and we have really good analytic features that can be used to build new features into the column store. Okay, now I'm going to kind of segue here into a new topic about how we leverage existing technologies. So we want to make sure again that in-memory works with our existing Oracle technology. So what better way to demonstrate that than Exadata today? So Exadata, as many of you know, is Oracle's premier database machine. It's designed to run Oracle as efficiently as possible using the best of breed of hardware. The compute nodes sit on top, and they're separated from the storage nodes on the bottom. And storage nodes have huge amounts of flash arrays used as caches for things like smart scans. When we have in memory today, in memory is stored in the compute nodes in the DRAM sitting in those servers, okay, in those blades there. With in-memory on Exadata, in-memory extends the processing to storage. So what that means is that the same columnar data formats that are in DRAM on the compute nodes are also used in the flash cache. The same in-memory optimizations that I talked about earlier with the vector processing, with the various different analytic features I talked about, can be exercised and used on in the data stored in the in Flash as part of the in-Flash columnar scans. Okay, what you get with Flash is the columnar capacity. Now, instead of limited to whatever DRAM capacity you have on the compute nodes in some number of terabytes, you're now talking about hundreds of terabytes, right? Hundreds of terabytes of columnar processing. Okay, and this is completely automatic. Okay, we call this feature in Flash columnar scans cell memory. And cell memory is the technology that literally powers the autonomous database. Underneath it, you are always running cell memory, which is running with in-memory in the flash drives. Okay, completely automatic. You do not need to specify, hey, this table, which table is in memory or not. It automatically gets populated in the flash cache. Okay, as part of building on top of this, again, this notion of we want seamless use of database in memory, we have something called self-driving column store, in-memory self-driving column store. So we want to be able to automatically manage what tables are populated and or evicted from the column store using heatness. Okay, so if you look at the picture on the left here, you have the column store and you have hot data, you have intermediate data, and you have cool data. And we provide the brains here that will determine which tables to evict because they are cold and which tables to populate because they are hot. If we didn't have this feature, the DBA would have to determine what that set is and then manually evict and populate. Okay, and we go further than that. We have different levels of this automation depending on your use, what you desire. But at the most extreme levels of high levels, you're basically telling us, please optimize the column store for both space and performance. So for example, you might want to auto compress those cold columns. I don't want to necessarily evict them out, but I do want to make room for hotter tables. So compress those columns that are rarely, if ever, used. Okay. Okay, so what's new? And again, like the picture describes here, we start off with these foundational building blocks and we're building on top of them to design newer features that we think real-time enterprises need today. So going back to the example of the self-driving column store, this is an area that we believe is very hot, especially in the context of autonomous databases today. The key thing that was missing was you had to declare which tables you want in the column store. And at the high level, we take that away. We will automatically mark all tables that are accessed for in memory. And then we will, as I mentioned, evaluate, check the heatness of those tables, and then determine whether they should reside in the column store still or be evicted out. We more aggressively compress cold columns. We use these new auto mem compress levels to tell our system how aggressively to compress for space or reformat for performance. Now, where are we going with this? Okay, so part of this talk is also describing what's the direction that we're heading here. And the idea, and really the direction is simple. We want to keep being smarter and smarter and smarter. So for example, we want to be able to automatically decide what the best size is for your column store. given the type of workloads that you're running, be able to predict the type of workloads that you will be running. And so to size things appropriately, compress your columns appropriately, etc. So that's the direction that we want to go to make this completely seamless, completely autonomous for you. Another direction that we are heading to is something called converged analytics. Tirthankar and Rich talked about this. Converged analytics is the idea that the Oracle database is really a one-stop shop. That's how we firmly believe in that. All of the sort of multi-model databases out there today, these specialized databases, they exist for a reason. There's a performance aspect to it, but there's a lot of limitations as a result of it. And we believe that we can address those limitations as well as address the performance that's desired by customers that want these analytics. So in this example, we're looking at spatial. Okay, so we have new in-memory only spatial summary column for each spatial column. So if you look at the example on the right here, you have a spatial object as defined in the spatial details column. And spatial objects are not, they consume space. Every point of that object is stored in your table. But oftentimes you're going to run a query, as the query on the right shows. It says, hey, I want to know which parcel is this utility valve in. Okay, which parcels is this valve in? And so you're going to search through 140 million US land parcels just to determine which of these parcels has this utility valve. If you run a spatial query, imagine having 1,000 points of floating points and then doing a check for each one of those points to decipher whether that utility valve is there. So what we do is actually build a spatial summary, which basically represents like a box around that object that you can then filter against to determine whether the item that you're looking for is within that box or not. And believe it or not, that the queries against this box are again leveraging vector processing. Okay, the SIMD instructions that will allow us to look at 64 of these spatial objects in one cycle. Okay, that's how we can get up to 10x faster with these spatial queries.
Hey, Shashank.
Yes.
Sorry, you might have to wind up quickly.
Okay. So I'm going to skip on text, and I'll talk about this last thing with vectorized analytics here. In this case, we are looking at making joint processing, and essentially all SQL operations above the table scans leverage the vectorized analytics that we have today. Okay, so leveraging SIMD processing that we discussed previously. Okay, I will skip the base level because that's been discussed already, and simply talk about this miscellaneous set. So we are looking at all sorts of aspects: hardware acceleration, converged analytics, pushing down more functionality to Exadata, keeping the data more compressed in the column store without requiring decompression, looking at external tables and populating them into the column store, and also looking at new hardware memory technologies like persistent memory to give us larger column stores. Okay, that's the future of our technology and what we're developing going forward. If you want more info, here's our blog. Our PMs maintain this blog diligently, so please take a look at that blog and reach out to us if you have any questions. And that's it. Thank you very much.
Yeah, thank you, Shashank. Very insightful presentation. Yeah, I like what you said. We can store anything in the scratch area and then optimize it. So yeah. Our next speaker, again, another technology champion, is Andy Ravenous. Andy is a product manager at Oracle for database in memory. Prior to that, Andy has worked on many other Oracle features and capabilities. Today, he will talk about database in memory tips and tricks for getting started. Andy?
Hey, Ranjan, can you just point out to the results that the poll results that Tirthankar published?
Maybe we can do it at the end. So Andy, maybe you can continue, and then we can, towards the end, we can publish the poll. Yeah.
No.
Yeah, Shashank, can you stop sharing, please? Thank you. Hello, everybody. My name's Andy Rivenes. I'm a product manager, as Ranjan said, with database and memory. And so today I was going to talk about some best practices. Actually, let me go back for a second. My email address is there if you have questions. You can follow me on Twitter. And then I think we've had a couple of mentions to our blog. So I kind of consider it the portal to all things of database and memory. So I highly recommend that you check that out. We have a resources page, and I'll have a link at the end of my presentation for that. I'm just going to cover the highlights. We're not going to have a lot of time to dive into a lot of the details, but I did want to point out that because of that, we do have a couple of documents that do dive into the details. So we have on our resources page both a quick start guide and an implementations guidelines. So I go into a lot of detail there about how to make use of database and memory, both for your applications and for other features of Oracle database. And then of course we have our documentation. We have our own database and memory guide in the documentation, so you can also use that as a reference. Analytics, database and memory. Hopefully you've gotten kind of a feel for that database and memory focuses on analytic queries. We're not really focusing on speeding up DML, insert updates and deletes, or OLTP workload. It's really a mixed workload, real-time analytics, reporting type workloads is what database and memory is targeting. And I think we've also heard a little bit about the row format being OLTP oriented, the column or columnar format being analytic oriented, and the ability for database and memory to actually use both. Very easy to set up, set in-memory underscore size parameter, that's the in-memory part, and then enable objects to be populated in the column store, whether it's an entire schema or whether it's just a few very active tables, partitions, subpartitions, even materialized views can be populated in the column store. And then later, it's possible you could drop your analytic reporting indexes. This can provide a significant capacity reduction, workload reduction in having to maintain those for OLTP transactions. And database and memory is basically available everywhere. Database and memory was first introduced in 12.102, and has been continually updated through 12.2, 18C, 19C, and then now 21C. It's available in the cloud, the extreme performance versions, the Exadata cloud services. We heard ADW, or Autonomous Data Warehouse. We support that with Flash. Obviously on premises, so we had a question about that. And since 12.102, it's been available in on premises. And then even Oracle Database XE supports database and memory. So how do you know if you'll benefit from database and memory? The in-memory advisor. So you can download the in-memory advisor. You don't have to enable database and memory to make use of it. You do have to have the ability to access AWR and Ash data, but you can download database or the in-memory advisor, run it against your Oracle databases, preferably during active workload sessions. So you can basically uses AWR snapshots, and it will identify analytic processing or workloads that it thinks will benefit from database and memory. It'll specify SQL statements that it'll think it'll benefit, objects that you could populate in the column store. It'll give recommendations, and it'll even give you the SQL to implement it. So the alter table commands if you want. Another tip, use the latest version of Oracle database. Now, obviously we're going to say use 19C, but even if you're using a previous version, 12.102, 12.2, 18C, it's really important that you apply the latest patches. So for 12.102, we were back in the days of the database proactive bundle patch. And then with 12.2 and newer, the release updates. And so I've included two MOS notes here that detail both for 12.102 and then 12.2 and higher, like 18C, 19C, how those patches work. But our fixes for database and memory come in those patches. So customers will sometimes say, well, we use PSUs, and you need to switch from PSUs to either the database proactive bundle patch or release updates in order to get the most current fixes for database and memory. There's just no reason to reinvent the wheel and have to get support involved for fixes that are included in those updates. And then for upgrades, a lot of folks will be upgrading their database if they want to make use of database and memory, either in the previously was going from 11.2 to 12.1 or 12C, even going from 12C to say 19C, since it's the long-term support release. One of the big things is take a look at all of your initialization parameters. Folks typically will carry older parameters along with them, and you need to reevaluate it because database memory does use so many new features that you don't want to prevent the optimizer from being able to choose an in-memory plan because you have some older, perhaps unused initialization parameters set that prevent that from happening. So reevaluate that. Again, this is all in our implementation quick start guide, but I'd like to make sure folks understand that they really do need to reevaluate that to make best use of database and memory. Don't steal memory. So we've talked a little bit about this in-memory area. We're going to set in-memory underscore size. So this is the in-memory part of the database and memory option. In other words, we're going to allocate this in-memory area, but you don't want to steal memory from other parts of the SGA to make room or to give you the ability to allocate the column store, because it's very likely that workload will suffer. So please this is the in-memory part, add additional memory to support the column store. Don't steal it from other parts of the SGA. And by that same reasoning, don't steal it from the PGA either. Now that typically with analytic workloads, you're going to be looking at much larger data sets. You'll still need PGA memory to allow Oracle database to run, SQL queries to run, do sorting. And so don't steal it from there either. And lastly, don't forget to, don't just allocate as much space as you need for all of your current data. You know, most systems, excuse me, grow. And so as data grows, this is kind of the capacity part of this, got to make sure that you have enough room for that data to grow within the column store as well, because even though all DML activity will occur in the row store, we'll reflect that data and populate that data in the column store as well. So as data grows, you need to have enough room in the column store allocated to be able to fit that new data. Now, before somebody asks or thinks about this, if say you do run out of data, it is possible to increase the column store size. Again, we're constrained by the SGA, but your queries will still run. We'll access all the data that's populated in the column store, but then we'll have to go get the other data that didn't fit from the row store. So we want to try to avoid that. That's coming up as another best practices to make sure that all of your data is fully populated. So again, fully populate your data. We have several views because it would be Oracle database if we didn't have $V views for you to be able to determine what's available in the column store as far as size. $V in-memory area. So you've allocated the column store, how much space is being used by the column store. And you can see that in $V in-memory area. Then $IM segments tells you what objects have been populated in the column store, how large they are. I noticed the bytes not populated field. What I wanted to stress here is validating that you've populated all of your objects in the column store and that they're fully populated. Bytes not populated is your key to that. Just because the population completed doesn't mean that all of the data fit. You can still get a message that says out of memory. And so you want to make sure as a best practice that all of the objects that you're enabling for in-memory are fully populated in the column store. $IM segments is your key to figuring that out. What if you don't have enough memory? You just don't have enough. You can't steal it, as I said. you don't have enough memory to any more memory you can add, so you just have a limited amount of column store. Remember, the column store is a store, not a cache. So we're going to populate the entire object or objects you've enabled in the column store. So what do you do if you don't have enough memory? You have the compression advisor. It's been enhanced to understand the different compression levels. So you can run the compression advisor against your objects to see how much space they are going to take. In addition to that, there are multiple levels of compression. So don't just think that you just need to use the default level. If you're memory constrained and you can't fit all your objects, it's better to go to a higher level of compression than it is to miss out on the ability to use database and memory for those objects for your analytic workload. So we have multiple levels of compression because it wouldn't be Oracle if we didn't give you choices, but the default is mem compressed for query low. We have query high, capacity low, capacity high. So consider higher levels of compression, and you can exclude columns. So if you want to exclude columns that aren't being accessed for analytic queries, perhaps lobs, typically lob data isn't analytic in nature, you can save memory by only populating the columns that are being used for your analytic queries. Just as a caution, recall or remember that if you do exclude columns and then they're accessed in queries, we'll go to the row store to get that data. So there is a trade-off there. 21C, we have a new feature that takes care of some of that with hybrid scans. But the bottom line is in 19C and prior, if you do exclude columns, then if queries access those columns, will go to the row store. So you won't get the benefits of the column store. So be a little careful about which columns you do decide to exclude. Rack. How does database and memory work with Rack? With Rack, it's our ability to distribute the column store across Rack nodes. Since we don't ship IMCUs, and this trips up folks, we need to use parallel query to access the data that's distributed across the multiple column stores. So now you're not limited to the amount of memory in a single database server, because with a rack system, in this case, a 4-node rack system, we can have, say if you had 500 gigabytes of column store allocated on one node, you could have 2 terabytes of data allocated across all 4 nodes. We're going to distribute that data, so we're going to use parallel query to access that data. So by default, Oracle will populate the data either by row ID range, by partition, or by subpartition. You can control that. There's a distribute clause to the alter table command for in-memory. Bottom line is, since we're using parallel query, you want to ensure even distribution. And that requires that you have a DOP, this is the parallel query part, at least as great as the number of column stores in your rack cluster, or the number of column stores that you've distributed data across for database and memory. So in 12.102, we actually required auto DOP. We've relaxed that, but you still have to have a DOP, one way or the other, that's as great as the number of column stores involved in the query in order to get the data in memory, in the in-memory column store. Because remember, we won't ship IMCUs back across the column store to a single node. We have to access that data independently in each of the column stores, and then we'll just return the resulting row set back to the query coordinator. How does database and memory work with other features? For Exadata, we have some unique features with Exadata. Not everybody has Exadata, but Exadata leverages Exadata Flash. So now you can have your column store in memory and DRAM and in Flash. So your columnar footprint can be quite a bit larger. We support something called in-memory duplication or fault tolerance. We actually did a recent Ask Tom session on that. In-memory active data guard is supported on in-memory with Exadata. In other words, you can actually populate the column store on standby and run reporting against the in-memory data in the column store on your standby database. And we support automatic in-memory, which Shashank and some others have mentioned. And it's available on all Exadata flavors, on premises, in the cloud, cloud at customer. And multi-tenant, fully support multi-tenant. The CDB has the column store configured, and then each of the PDBs can use up to the total amount of the CDB. Obviously, you can't use the same memory, but you can carve up that memory in the CDB, and each of the PDBs can allocate an in-memory underscore size parameter or not. So they don't even have to use it if they don't, maybe some of your PDBs don't need to use in memory and some PDBs do. So you get full flexibility of multi-tenant with database and memory. And how do I tell if the column store is being used? This is a big question that comes up. Target the right workloads. As I said, DML activity is not going to make use of database and memory. Row by row processing isn't the right way to think about it. It's processing data in sets in the database, not run row at a time. And the thing I usually tell folks is if your queries are spending a majority of their time accessing data, joining data, or aggregating data, then database and memory is going to provide benefit. And that's really the key takeaway. I know we're right at the top of the hour. If you bear with me, I'm almost done, and I want to finish this up and be respectful of your time. So I just have a few slides, but this is a key part of database and memory and understanding the benefit that you're going to get when you enable database and memory. And what I always recommend to folks is SQL Monitor Active Reports. It's SQL Monitor Active Reports, something that's available as part of Oracle database, time-based evaluation of the benefit of your queries. And one of the cool things about database SQL Monitor Active Reports, and it is on our resources page, a link to how to set it up and how to interpret it, is this ability to see that if you notice here in the activity column, that the time spent accessing the data was spent CPU in memory. And that's really critical to being able to see the benefits that database and memory is providing for your queries. And don't forget statistics. We've actually had some questions today about that. So we have all sorts of session level statistics and statistics at the system level will show up in the AWR report that talk about the benefits that database and memory is providing for your queries. And also at the system level, things like population and repopulation. So don't forget session level statistics. We use session level statistics on a lot of our examples. So if you go back and take a look at some of our blog posts or our Ask Tom sessions, you'll see how we've used them. Scripts are available. There's a link on our resources page to scripts that show you how to make use of this. And what's new? I'm just going to basically say that starting in 12.1 and now with 12.2, 18C, our current release of 19C, look at all the features we've added. So we've added huge amounts of performance enhancing and automation to database and memory. And in 21C, we added even more. So we're continuing to innovate with database and memory. You don't have to know about all these features right off the bat, but as you start using database and memory, you may find that some of these features can further enhance your performance. And with that, the thing I'm going to conclude with is the base level feature. It's been mentioned several times. It was actually being released as part of 21C, but we backported it to the July 19.8 release update. Notice release update. So that's one of the other motivations for making sure that you're using the most recent release updates in your database releases. But the ability to use the base level feature or database and memory up to 16 gigabytes without having to license database and memory. We've done, again, a couple Ask Tom sessions and some blog posts on this. So if you're interested in this, take a look and try it out. You don't have to license database and memory to see just how great of performance it can provide for you. And with that, I'm going to conclude. That's the whirlwind best practices session, but I did want to make sure that everybody, that I respected your time, but that you got to see kind of what the key points that folks have run into that you can make use of so you don't have to reinvent the wheel. And our resources page, as I mentioned, has the list of a quick start guide, implementation guide, our YouTube videos, our Ask Tom sessions, and I shouldn't forget to mention our Live Labs environment. So if you want to try database and memory for yourself, we have a Live Labs environment that you can go out. You don't have to pay anything. You don't have to license anything. You don't even have to be registered for the cloud. You can just go out and set up a Live Labs environment and run database and memory and just see just how good and how fast queries can run when they're enabled for database and memory. So with that, I want to thank you very much, and I'll pass it back to you, Ranjan.
Thank you very much, Andy. And thank you everyone for staying a little longer. Tirthankar, do you want to summarize the poll result?
It's I published them. So yes, let me quickly go through this. So yeah, most people believe they work for a real-time enterprise, which is not surprising. Interestingly, 11% said neither yes nor no. So I'm always curious what that means. I left that as a trick, third choice, but it always surprises me when someone actually picks it. Anyway, so I guess there are people that are in between real and not real time. Most people have basic knowledge of database and memory, which is good. And most people to get started or get going need help with more technology details. So one thing I'd like to ask is, let's keep this community going. Let's keep the LinkedIn group going that Ranjan has started, because we want this to be the first of continuous interactions. As you start getting further in your in-memory journey, we'd like to be able to come back here, ask questions, and get feedback, and maybe interact with your peers as well if needed. So please, let's keep this going beyond just this one-time seminar. But thank you very much for attending. I think this has been informative for me also, just from the questions I've been seeing on the chat. I think Ranjan's done a great job pulling this together, but thank you all for participating. Thank you to all the presenters as well. Any other final words? Anyone else, Shashank or Ranjan or Andy?
Yeah, no, thank you everyone for joining, and we have 3 other sessions planned, and please come to the next sessions. And again, like Tirthankar said, Summit is just the beginning of collaboration. Let's work together and build very exciting and powerful solutions for our enterprises. Thank you very much for joining.
Thanks.
And Ranjan, one of us should archive the questions and the poll results for.
Yes.
So will you be doing that?
Yes.
Thank you.
All I could say is this is Rich, and I learned a lot. It was great, and I know it pretty well already. You guys are amazing. It's amazing the depth.
Rich is very modest. Rich knows more than most of us do. So
No.
learned a lot is saying a lot. Thank you.
I'm going to tell you, you can leverage this to make things at least 1 million times faster. And with machine learning, it's going to be critical.
We like that. Thank you. Thank you very much, everyone.
That's it. Oh, there are 5 more questions.
Yeah, why don't we can sit around and just clean up the questions while people are.
Yeah, that's what.
Let's do that.
I was just about to leave and I saw 5 more.
Yeah, let's finish
No,
up.
most of them are thank you very much. Can I get the invitation to the other 2 sessions? Okay.
Yeah, Ranjan, do you want to answer that?
Yeah, I mean, if they can send me an email, I can forward the invite.
Samir.Mohanty.
Yeah, I'm trying to
Samir Mohanty. Oh, his email is that samir.mohanty@oracle.com.
Shailendra, can you capture that thing? I'm trying to capture the Q&A.
Yeah. So Q&A I have already, anyway, well, maybe the newer answers are not captured.
So are the presentations going to be made available? Ranjan, what's the plan?
So we plan to release the recording on the LinkedIn group, and later on we will decide to release at other places. So initially, I think everybody should join the LinkedIn group and let's start collaborating there. That's the place we will kind of release the recording as well as the new blogs and other things. And then we can, decide to release at other places as well later on.
Ranjan just send you an email with the email address.
Sure.
I was going to say, if you guys send me your talks, I will try to tweet some of those slides here and there over the next few weeks.
Sure, I'll be happy to do that.
Yeah.
I'll just say this is from the In-Memory Summit and kind of push them to the LinkedIn
Awesome
place. So you need a lot more people there. You guys have no idea how great it is to get immediate answers to certain questions. There are some really good questions out here. You guys answered them well. Really great job. Really well done. I've seen Andy and Tirthankar before, and they're always great. But Shashank, that was a great job as well.
Thanks, Rich.
And Ranjan, I appreciate you asking me to be here and coordinating this. This is great. I'm gonna put this in all my talks to say, hey, get get to be a part of this.
Yeah, no, Rich, thank you for joining. And again, we're gonna be presenting in the evening, right? So you're gonna be there as well. So yeah, thank
be
you for your
there.
time.
Oh, Rich is doing a repeat
10
show.
hours.
Okay, all right, great.
Be there.
Okay,
gonna-
so did we answer all the questions? So then we can end the webinar,
Yeah.
unless people are still asking questions.
Oh,
No,
actually,
don't do it yet. We still got some stuff.
Okay, keep going then. Yeah, I mean, if people have questions, yeah, please feel free to post questions. If there is a last minute question, we can answer it.
And Ranjan, if you could do a recording or I could do it live. I don't care which. If it's easier to do, you tell me now, I think.
I think the live one will be good if you're Rich, if you're able to manage it somehow.
Absolutely.
Okay,
Absolutely.
thank you so much.
So Ranjan, the other
Yeah,
sessions will be
Hold
recorded
on,
as well, right?
let me stop the recording. So
Yes, that's a good idea. Great
yeah.
idea.